Welcome to my channel. In this video, we will be solving a very interesting trigonometric equation that says cos to power 3x plus 11 tan x cos squared x minus 29 cos x is equal to 0. It sounds scary just reading out the question, but I can assure you that the steps are very simple if we can remember the steps, and the problem is very simple to solve. But we need to first of all make a substitution. This tan x is what makes it a bit difficult to solve. Before I proceed, I would like you to like this video, subscribe to my channel if you haven't done so, and also share this video. Then I would also like you to leave your comments in the comment section. Solution. Let us remember that tan x is equal to sine x over cos x. We will now substitute sine x over cos x for tan x. It will make tan x disappear, and then this cos x will cancel one of these cos squared x. So cos squared x is cos x times cos x. This is one way we can express it. Another way is to express it like this: cos x all squared. So this is the same as this, as it is the same thing as this. So putting sine x over cos x here, we now have cos to power 3x plus 11 sine x over cos x, cos squared x minus 29 cos x is equal to 0. So this will cancel one of these, as I've explained here. It simplifies into cos to power 3x plus 11 sine x. There's a cos x remaining, cos x minus 29 cos x is equal to 0. So we'll have to factorize cos x out. Factorizing, we have cos x bracket cos squared x plus 11 sine x. The cos x is now here, minus 29. This cos x is being factorized out, is equal to 0. So let us equate each of these terms to 0. The first one is cos x is equal to 0. And if we find the cos inverse of 0, we'll have x is equal to 90. When you punch your calculator, shift cos 0 will give us 90. So x is 90. It is important to note that the cos inverse of any number is not the reciprocal of cos of that number. The reciprocal of cos is 1 over cos. Let's say x. It is the same thing as secant x. However, the cos inverse or arc cos any number is the inverse cos function of that number. Let us proceed. Now, we now have these terms inside the brackets to equate to 0. So cos squared x plus 11 sine x minus 29 is equal to 0. I need to express this term such that they will only appear in terms of sine x. To do that, let's make this substitution: cos squared x plus sine squared x is equal to 1. So let's make cos squared x the subject. It becomes 1 minus sine squared x. So let's plug in 1 minus sine squared x, where we'll have cos squared x in the question or in the equation. So that becomes 1 minus sine squared x plus 11 sine x minus 29 is equal to 0. Now I'll move this one here and then multiply through by minus 1. If I move this one here, it becomes sine squared x minus 11 sine x plus minus 29 plus 1 is minus 28. So I have plus 28. Yes, because I am multiplying through by minus 1 is equal to 0. Now, let us make a substitution rather. Let sine x is equal to a. Now we'll put in a for sine x in the equation. A squared minus 11a plus 28 is equal to 0. I now have a quadratic equation. The sum is minus 11a. The product is 28a squared. We will now look for the product of 28 such that when they are added, we will have minus 11. The factors of 28 that will give us minus 11 when they are added are minus 7 and minus 4. Yes, minus 7 and minus 4. So a squared minus 7a minus 4a plus 28 is equal to 0. Let us group. In the first bracket, a is common, a minus 7. In the second one, minus 4 is common, a minus 7 is equal to 0. Let's take one of these two brackets that are the same, a minus 7, and then put the other ones in a bracket equals to 0. So if we equate each bracket to 0, a is equal to 7 and a is equal to 4 rather. Now, to finish up, let us remember that we made one assumption. That assumption is let sine x is equal to a. So when a is 7, sine x is 7, and x is the sine inverse of 7. And the sine inverse of 7 will give us no real solution. If you punch your calculator, you will have math error. The same thing here. When a is 4, sine inverse, sine x equals to 4 rather, and then x equals to sine inverse of 4 also will have no real solution in this case, because when you punch your calculator, you will get a math error. The reason is this. If we plot the graph of sine x, we will get the maximum at minus 1 and plus 1. The maximum here is minus 1 and the maximum here is plus 1. So we don't have 4 and 7 in the graph. If we also plot the graph of cos x, now we will have a graph like this. The maximum is also at plus 1 and the minimum is at minus 1. And then we'll end like this. So this is the graph. So for sine x, minus 1 and plus 1 are the range of value. So 7 and 4 are not within. Also for cos x, the graph is from plus 1 to minus 1, which are the range of value. So the answer or the solution to this problem, which is cos 3x plus 11 tan x cos squared x minus 29 cos x is equal to 0, is x is equal to 90 as we have it in this case.